Hey 8th graders, so this video is mainly for DLI kids, as A and B cohort will be doing this lab or a different version of this lab in class. If you guys are watching this because you were absent, then obviously you're following these directions for DLI. So here is your lab for today. Your learning target is to collect data to compare and contrast magnetic force of strong versus weak magnets. So we're really zooming in and looking on the different forces exerted by strong and weak magnets, okay, and how that changes the energy of the system. Okay, moving on to slide 2. Here are your directions again. AB, you guys are doing this in class. AB kids, unless you are absent, you guys will be, hold on one second. You guys will be completing slides 3 through 11, but if you're absent, you guys will be doing strictly DLI. So DLI kids, you are only doing slides 12 through 18. You guys can skip right over the next couple slides. So I'm going to go ahead and skip 3 through 11 and start right on slide 12 for you guys. So here is your guys' lab for today. Okay, so for part 1, and there's 2 parts for you guys to be doing today. You guys will be opening the sim link, so you guys can right click on that and hit open link. So in this part, you will use the Amplify simulation to help you test similar scenarios to the lab, so what the AB kids are doing in class today, and then you will answer the questions. On the left-hand side of the screen, add a strong magnet and lock it into place by clicking and dragging the lock. So left-hand side, here's my strong magnet, and I'm going to go ahead and lock it into place. Okay, and then I'm going to grab, so magnet is red side up, and then place an iron bar toward the right, 20 vertical grid lines away, and then click run and observe. So here is my iron bar. I'm going to place it 20 grid lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I almost had it, so I'm going to move it over 1. Okay, and then go ahead and click run and observe what happens. Okay, so what you guys will need to do, and I'm not going to show you guys exactly what happens, is you guys will need to collect data for that. So for this one, you guys are just doing some qualitative, so telling me a little bit about it. There's no numbers that you're collecting yet. So observe what happens to the potential energy. So if you guys look in the top right hand corner, you guys will see potential energy, and as our system here reacts and responds, you guys will see changes in that. So observe what happens to the potential energy as the iron bar moves closer to the magnet. What trend do you notice with the potential energy? So what I'm asking for there is, does the potential energy increase, does it decrease, or does it stay the same? Okay. And then finally click analyze and rewatch. Okay, remember you have that little blue bar at the bottom here that you guys can click and drag. Sorry, I can't go there because I haven't ran it. But there's that blue bar at the bottom that you guys can click and rewind. So click analyze and rewatch. Focus on the numbers on the right for kinetic energy. So you have that little graph over on the right hand side that shows you potential and kinetic energy. So focus on the bar that says kinetic energy, and then also underneath you guys should have a numerical value for kinetic energy in joules. Okay, explain what happened to the kinetic energy throughout the whole movement of the iron bar. So from the start when it was 20 grid lines away to when it snapped in place with the magnet. Okay. And finally, now replace the strong magnet with the weak magnet and rerun this experiment. So you guys are going to want them to be attracting. So you're going to get rid of this bar here. And we're going to bring in a weak magnet in that same spot. Make sure you guys double count your grid lines. I think I might be just a little bit off. Okay. And make it so it's going to move towards it. So make that attracting. Okay, now do the same kind of thing. Observe what happens when you hit run to that potential energy in the upper right hand corner. Do you have any trends you see? So how did the potential energy of the weak magnet system differ? So was there more potential energy? Was it the same? Was there less when you guys used the weak magnet versus the iron bar? Okay, and then how did the kinetic energy of the weak magnet system differ? So again, go to analyze and take a look at the differences in kinetic energy that you had compared to just the iron bar. Okay, next part 2, you're going to rebuild your system. Start with a lock strong magnet on the left-hand side, so that's the magnet you guys have out and locked right now, and then add a second strong bar magnet as close as you can to the first. So I'm just going to kind of show you guys what the kids in class did to test this similar theory. You guys will collect data a little bit differently than they did, but they basically had 2 repelling magnets. They held them together, and then they always held the left-hand side together. They then let go of the right magnet, and they saw how far apart those two magnets moved. Okay, then we went through and we switched. Instead of two strong magnets, we used a strong and a weak, where our strong was held in our place and our weak was moved, and then switched up. So you guys can see the different combinations they used and how they set up their data. You guys will do something similar in the Amplify simulation, where you guys have two repelling magnets. So you guys will start with two strong magnets. You'll put them together as close as you can, and then you guys will hit run and see what happens. And then you guys will collect some data using the simulation. That's, again, a little bit different than what the kids in class were able to collect with their hands-on experiment. So you guys will look at this data table. What's the maximum potential energy? So if we were to analyze our experiment and drag it back to the beginning where the two were held together, that should be your maximum. So it looks like 14,339 joules. Okay, versus what happens to the potential energy as the magnet moves away. So does it go up, does it go down, or does it stay the same? What's the maximum kinetic energy? So again, examine that chart over here to tell me what the maximum kinetic energy is, and then what happens to the kinetic energy as the magnet moves further and further away. Okay, then change up so where you guys have a weak magnet locked in place over here. Okay, let's go ahead and rebuild. Yes, weak magnet over here, locked in place, and then another weak magnet right next to it repelling. Okay, that's your guys' second test. Weak and strong, or excuse me, strong held in place and then a weak. So your left one will be a strong magnet, and then paired with a weak, and then vice versa where this one is held in place. And then finally, I think that's your last one, so weak held in place and a strong. So collect data for all four of those magnet setups. And then which system had the least amount of potential energy in it, and which system had the most kinetic energy. Okay. Once you guys have finished just those slides 12 through 18, that's all you have to do on this assignment. You guys can go ahead and double check it, make sure it's complete, and turn it in. And I hope you all are having a great day. Please let me know if you have any questions. Thanks.